Whenever you peel off a section of tape from Scotch tape, like I have right here, large electrical currents are produced, kind of like tiny lightning on the surface of this. We don't really know why. It's not quite the same thing, but look at how much static electricity you produce when you are pulling plastic wrap off of a giant roll. Yeah, kind of like that, but when you do that in a vacuum with Scotch tape, so there's no air around, say you were in space, you pull that and those tiny electric currents create X-rays. Enough X-rays that if you were pulling this at just a leisurely pace here, it would be producing enough X-rays in a vacuum to image your hand, like an X-ray. I mean, it doesn't happen here because all the air and stuff gets in the way. Hello and welcome to another edition of Because Science Footnotes, the show where I post a sciencey video and then I look across all of the places where I posted that video for your comments, questions, and corrections and face them head on so that we can all become smarter, especially me. I have to read all of the comments now. It's a lot. So on the last episode of Because Science, we went all the way back to the latest Star Wars film, Star Wars: The Last Jedi, and we addressed the supposed plot holes that had to deal with scientific accuracy that you sent me. I said they are all more or less explainable with science. They all had to do with space. Leia could probably pull herself back to her ship. Bombs could drop down in space. They wouldn't just float. And ships could appear as though they slowed down in space when they ran out of fuel. But what did you have to say? The first comment comes from Coran Horn, who says, I don't know what he was talking about here. This is from the novel and other canon sources. Blah, 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 blah. The bombs would drop through sequenced electromagnetic plates in the clip, which propelled the bombs to drop in microgravity environments. The bombs would then be drawn magnetically to their targets. So this is in reference to what I said, that the bombs could drop straight out of a bomber if that bomber was over a planet. In the first scene of The Last Jedi, the opening battle scene takes place over a planet, and because you have to go really, really far away from a planet to get low influence from that planet's gravity, there'd still be enough gravity for those bombs to drop down from the ship towards the planet, and if the dreadnought was under the ship, then it could blow up the dreadnought. But canon in the visual dictionary for The Last Jedi says that they are magnetically, the bombs, magnetically propelled towards their targets and attracted to their targets. Magnetically propelling the bombs is just fine. That could launch them out of the bomber, and once they were in space, they would continue on at a constant velocity. Sure, fine, that's the canon answer, but I think I ignored it because magnetic tracking technology, being drawn towards a target magnetically, adds more problems than it's worth. The problem with magnetic tracking technology, as opposed to just relying on gravity for these bombs to direct themselves towards their targets, is that magnetic field strength decreases with the cube of the distance between the source and the target. That's really, really fast. It will decrease. You can try this with your own bar magnet. Take a bar magnet and put some ferrous metal next to it. Now, it will be very attracted to it if it's very close, just like that. But if you've ever played with a magnet before, you know if you pull it just a little bit away, there's almost no attractive force anymore. That's because the attraction decreases very, very, very quickly, cubed with the distance. So if you released a bomb and it was any significant distance away from its target, then using magnetism to attract it towards that target would be horribly inefficient. You would need very, very strong magnets or some other weird, hyper-sophisticated magnetic tracking technology that gets around the problems that this technology would create. And if it was just attracted to any metal thing, it would drop from the bomber and then just go back to the bomber because that was the closest thing. So I don't think that's as good of an answer as just allowing bombs to drop under gravity. Our next comment comes from Jake M, who says, here's a plot hole I thought of as I watched this. How can anything be out of range for a weapon in space? I guess you could say that the targets could maneuver to avoid being hit, but that seems unlikely given the velocity of the projectiles. Interesting question. If you want to talk about the reality of space war, you have to deal with the fact that there's no air that projectiles need to travel through, and there's nothing to get in the way of any direct shots. So lasers and very fast projectiles, kinetic kill vehicles, if you will, are very, very good in space, and they have very extended ranges compared to what they would have on Earth. However, bullets, if you fired a bullet in space, you're right, there is some maneuverability there. That's how you could get out of range of a kinetic projectile. If two ships were many kilometers away from each other, even if a projectile was going many kilometers per second, that ship would still have some fractions of a second, if not seconds, to make small adjustments to move out of the way of that projectile if it's not directing itself. If it's just like a bullet, a ship, if it is far enough away, will have some seconds to change that utilize just small changes in angles that relates to larger distances when you're very far away in space. So maneuverability does get into the out of range problem. The other thing with lasers, even though they travel at the speed of light and you can't dodge them if you are sufficiently close, their intensity, their power, does decrease with the square of the distance between the laser and the target. So at some range, depending on the power of the laser, there will be a range where they are ineffective, or they are just not heating up the hull of some spacecraft enough such that it's not causing any damage. So both kinetic kill vehicles like bullets and lasers do have some effective range. That's why you'd have to stay out of the range of the First Order. Our next comment comes from Sean Baugh, who says, "Hey Kyle, let's be honest. There's the biggest plot hole in The Last Jedi and Star Wars as a whole revolves around Wookiees. They are 7 to 8 feet tall, 300 to 400 pound behemoths, covered from top to bottom in long, dense fur, including their fingers. There is absolutely no doubt that they must have at least half dozen coconut-sized dingleberries swinging from their butts like Christmas tree ornaments. Is there a scientific explanation for why anyone within 3 feet of, say, Chewbacca doesn't start gagging immediately? Is it just fear of getting their arms ripped out of their sockets if they say anything? Or is it simply the will of the Force? It's your responsibility to use your advanced intellect, no, to make a video addressing this huge plot hole. The people, no, we deserve, no, demand answers because science, whoa." Maybe Wookiees clean themselves like cats. The next comment comes from Valius, who says, "The biggest plot hole with Leia is that there's one door between space and the ship, so how could they get her in without jettisoning themselves out into space?" Well, let's check Director Ryan Johnson's tweet response to this. Oh. It's an airlock and there was another door, so the air could be locked in. Huh. Our next comment comes from Get Good Scrub, who says, if Leia would have a lightsaber with her and turn it on in the opposite direction she wanted to go, would the lightsaber act like plasma propulsion engine and move her through space? You know, my knee-jerk reaction to this was no. But then the answer actually is yes. It's actually really, really interesting. So if you just had a massive heat source, I say that lightsabers are putting out megawatts, millions of watts worth of power. And a lot of that is radiating in the form of heat at the lightsaber. That's how it goes into stuff. Now, if you're putting out that much heat, photons of light, infrared light, are coming off of the lightsaber. That's how the heat is radiating out into space. Those photons do carry some momentum. So if they were to leave an object, they will produce a slight recoil on that object, kind of like a rocket ejecting fuel from it. In theory, if you held a lightsaber behind you in space, you would start to go. not backwards, just that way. There's a really interesting real-world application for this. It's called the Pioneer anomaly. So for the spacecraft, Pioneer 10 and Pioneer 11, as early as 1980, scientists started noticing that there was some weird accelerations that were putting the spacecraft off course. Accelerations coming from something that they didn't know what it was. They had no idea what was producing the accelerations. What they eventually found as they upgraded equipment and looked into all the numbers was that the Pioneer spacecraft were emitting heat not equally in all directions. So one direction had more heat coming out from it. And like those photons of light having a little bit of recoil, because more heat was coming out of one side, it was accelerating these spacecraft slightly off course just because of the heat that they were putting out. Although this thrust is minuscule. I found a paper that suggested if you were using really inefficient heat propulsion, which a lightsaber would be giving you, it's not directed or anything, you would have to, for just 1 meter per second of acceleration, kind of like, around something like that, kind of what Leia is doing in space, you would need 100 gigawatts of radiating power. If I assumed that 35 megawatts is the power output for a lightsaber, this is at least 1,000 times more than that. Like 3,000 times more than a single lightsaber. So Leia, with 3,000 lightsabers behind her, could start getting back to the ship, but also she'd be on fire. Bad. But the super nerd comment of the week goes to Jonathan Bronico, who I think I mentioned last week, who says, many people comment that Rey didn't have a lot of time to train on that island. But what if the perceived difference in time was because of time dilation? He then goes on to use an equation for time dilation that I used in the Han Solo time travel episode to say, basically skipping the math, if Rey was on the island, but everyone else in the movie was jumping to hyperspace, when they were jumping through hyperspace, because of time dilation, they would experience their own time, but the rest of the galaxy would experience more time than they would. Because the hyperspace people, their clocks would be ticking more slowly, which means Rey could get more time to train on the island, relatively speaking, to everyone else who was doing all that lightspeed stuff. That is a really, really cool answer. I mean, the easiest explanation is that the events that Rey was going through and the events that everyone else was going through are just on two different times that weren't perfectly tracking, and then they met and then they were at the same time because movies. But the time dilation thing is so smart and so fascinating. I love it. Although it would make Luke and Leia not the same age anymore. And a lot of other weird stuff, even though they're twins. Twins that aren't the same age. That happened. That happened. We sent one twin into space for a year in the ISS, the Kelly brothers, and one stayed on Earth. So they are twins that are not the same age anymore because the twin that was orbiting Earth was aging slower. Cool. But how could she learn the Force in just a couple of hours? It's fine. How long was Luke training for on Dagobah? Like a Dagobah? So congratulations, Jonathan Bronico. You are indeed a super nerd. Wow! I'm working on my voice reel. You are indeed a super nerd. Nice. But of course, I'm not always right. Sorry, I was just thinking back through my past failures. So what did I get wrong this week? Supposedly. Our first correction comes from a lot of people, bing, 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 bing. I hope that matches up, who all say some variation of, I said Leia, to pull herself back to the ship, would be using equal and opposite forces. So if she pulled on the ship, her ship, the ship would pull on her with an equal and opposite force, and because the ship has so much more mass, it would hardly accelerate, but she would accelerate towards it. What everyone said in all these comments is that if that's how the Force works, equal and opposite forces, then if Yoda lifted Luke's X-Wing on Dagobah, then if he's providing enough upward force to lift a spaceship, it should be the Force should be providing enough downward force to smush Yoda into green something, or force him into the ground, or sink him into the Dagobah dirt, or the ground would crack, or some variation of that. And I think you are all right. The problem is, we just have to choose. We don't know what the Force is, and we don't know how it works. A lot of you were saying, well, because we don't see those other effects on Yoda when he's lifting the X-Wing, the Force has to be some loose force or disconnected such that it doesn't have a force pair. There's no equal and opposite reaction, and Newton's third law doesn't exist. Sure, you could do away with Newton's third law in the Star Wars universe, and it might help explain something like why Yoda isn't dead when lifting an X-Wing. But if Newton's third law doesn't apply in the galaxy far, far away, in our universe, then a lot of other problems present themselves, like the fact that characters wouldn't be able to walk because Newton's third law and friction at your feet and the resultant forces there are what make you walk. So either we have to apply real-world physics to just parts of Star Wars because it's a movie, or you apply real-world physics to all of it and none of it makes sense. I prefer the former because you can learn something. What I'm saying is this is one of these cases, it's kind of like midichlorians, where we have to make a decision. What explanation do we want to go with? I go with the one that works for most situations. We can't have it all, unless we start making stuff up. That sounds like a movie. Our next multi-comment comes from Tristan M. and Oscar Bogenberger Damsel, fancy, who say, but in the opening scene, it doesn't look like the planet is perfectly below the dreadnought. Looks like more on a 90-degree angle. So if the bomber dropped a bomb, wouldn't it go sideways and not at the dreadnought at all? That's a good point. If it is only under the influence of gravity, the bombs towards a dreadnought, then yes, that would be a problem. Although, if you look back at the movie, the planet is so big that perspective-wise, it is hard to tell where the ship is in relation to the actual surface of the planet. I don't know if it is directly side-on. It could have been like this or that. The bomber is small enough in relation to the giant dreadnought that the angle of the bomb would be small enough to be mostly down, and it would still be fine. I think. The scene is pretty ambiguous with the setup of all the ships, but you're right. If it was straight up and down, for example, on the surface of the planet, it would miss the dreadnought entirely. Then you would need something like propulsion or magnetic attraction, even though magnetic attraction is the worst of those possibilities, I think. Our next correction comes from Jordan Sullivan, who says, by your own admission, they were in battle and running away from the First Order. I mean, it's not my admission, it's the movie. It makes no sense for Leia to somehow be in front of the Raddus, her ship, to be able to pull herself in. So what happens is Leia is in the Raddus, and she gets spaced, and it looks like she is out front. I think what Jordan is saying is if they are trying to run away from the First Order during this, why is she still in front of it? I think it's because, it sounds weird, but I think it's because everyone inside of the ship is going the same velocity as the ship. If you're in an airplane, you're not thrown out the back of the airplane because you slowly accelerate with the airplane up to its cruising velocity, so you are also going 500 miles per hour or whatever it is. So at the time that Leia is spaced, she is going whatever velocity the Raddus is going. So if she is ejected forcefully from the front, she is now going that velocity plus whatever her ejection velocity was. So if she was ejected, she would continue on in front of the Raddus at that new velocity, whatever it is. It would be this plus the ejection velocity, and she would still stay in the front of it. But you're right in that if the Raddus was accelerating and they were both at a constant velocity, and then Leia got spaced, she is no longer accelerating. She doesn't have any thrust, so the Raddus would start to pass her as they traveled through space. I think there's enough wiggle room here in how the physics is portrayed that she wouldn't be immediately passed by the Raddus. They are going some significant velocity as the Raddus is accelerating. She is then spaced, and they're continuing, and the Raddus might be slowly overtaking her, but she's not in space for all that long. So, I think it can work. But our super nerd correction of the week goes to Toby Toastbrat. Weirdo. I don't know if you're weird, you just have a funny name. Who says, I don't think those bombers have anything to do with gravity. Those bombs get accelerated out of the bombers. What is in motion stays in motion. A space bomber that would need gravity to work would be pretty crappy when far away from any planet. Good correction. I think you're absolutely right. If you are using gravity of a planet, of a nearby planet, to help you drop bombs onto something in between you and the planet, it would be pretty bad if that planet wasn't there anymore. In this situation, if you were to drop a bomb now, it would be like standing on the surface of a planet and dropping something. You have a force that is pushing on your feet that is keeping you from being pulled towards the center of the Earth. And if you drop something under that acceleration going downwards, it drops down to the ground. But if you remove that pull of gravity, if there's no source of gravity near the bomber that can pull it down like a planet, then the bomber is just accelerating upwards. Then if you were to drop a bomb now, from the bomber while it was accelerating upwards, you'd let go of the bomb and it would go, and it would just stay at the same position. You're right, Toby, that would make for a pretty bad bomber. So congratulations, Toby Toastbrat, you are a super nerd. Wow. Range. So if you are subscribed to Alpha at projectalpha.com, you already know what the next episode of Because Science is going to be because you've already seen it at this point. You can go to projectalpha.com and sign up for a free 30-day trial and get Because Science episodes 2 days earlier than anyone else. But if you haven't subscribed yet, the next episode of Because Science will be magical. Ooh. That's right. In this week's episode of Because Science, we are boarding the train to Hogwarts. Actually, we're figuring out how to board the train to Hogwarts by calculating your chances of running through platform 9 3/4. Your chances, your actual chances of getting through that wall. They're low. but we can be more specific than that. So go watch the latest episode of Because Science if you haven't yet and tell me what you think, because each week for this show, I will be collecting your comments, questions, and corrections at youtube.com/BecauseScience, facebook.com/BecauseScience, and at BecauseScience on Instagram and Twitter. Follow me there, and I'll see you. Almost 1,000 comments on the newest video at the time that I filmed this. Keep it coming. And remember, we do deserve dogs because they were artificially selected. Natural selection works to give you organisms that have adapted over time based on their genetic makeup and genetic mutations that happen randomly and what works and what doesn't in nature. Dogs, or at least dogs as we know them, have been artificially selected for certain traits. So larger dogs, smaller dogs, dogs with spots, dogs with big heads that all have to be born by cesarean section. We do deserve dogs because we made them. You deserve what you get. What you get is a mutant wolf. Bye.